Everyone thought Russia's prize Su-57 Felon was invincible, but in a shocking twist of events that left even Elon Musk speechless, this sleek, shadowy aircraft worth billions of dollars, armed with devastating firepower, was reduced to twisted metal by a precision strike. As rumors go round about SpaceX's secret fighter jet program, could this be the moment when Silicon Valley disrupts aerial warfare forever? Has Russia's mighty Air Force finally met its match? Join us as we unveil the SpaceX fighter jet capable of beating the Su-57. The battle for aerial supremacy has taken an unexpected turn. As Russia's prize Su-57 demonstrates vulnerability in Ukraine, Silicon Valley titan Elon Musk steps into the ring with a groundbreaking concept that could revolutionize aerial warfare. What makes this showdown particularly fascinating is the stark contrast between old-school military might and cutting-edge innovation. SpaceX's X-1 is a radical departure from conventional fighter design. Unlike the Su-57's focus on raw power and speed, the X-1 embraces future-forward thinking with its autonomous capabilities and revolutionary propulsion system. Its compact space shuttle engine and advanced stealth features allow it to achieve hypersonic speeds of 4,600 miles per hour, more than twice the Su-57's top speed. The X-1's game-changing microwave technology can disrupt enemy electronics and even melt aircraft components, making traditional dogfighting tactics obsolete. The numbers tell a compelling story. While Russia struggles to maintain its small fleet of Su-57s, America's F-35 program has produced over 1,000 aircraft. SpaceX's X-1 aims to bridge the gap between these traditional fighters and the future of aerial combat. Its ability to operate at altitudes above 105,000 feet, well beyond the reach of conventional fighters, combines with AI-driven combat systems to create an entirely new class of aircraft. This clash between old and new represents more than just a technological rivalry, but a glimpse into the future of warfare. As Musk boldly stated, the fighter jet era has passed, and with autonomous drones and AI-driven combat systems becoming more sophisticated, traditional pilots might soon find themselves sharing the skies with intelligent machines. The success of the X-1 program could mark the beginning of a new chapter in military aviation, where the limitations of human pilots no longer constrain aircraft design and combat capabilities. As cutting-edge fighter jets reshape modern warfare, one question lingers in the minds of military experts worldwide. Could Russia's most advanced warplane be more vulnerable than anyone imagined? The Su-57, Russia's pride and joy in military aviation, is ambitious engineering, but with a surprising twist. Unlike America's F-35, which boasts over 1,000 aircraft in service, only 32 Su-57 have ever taken to the skies. This rarity makes each plane incredibly precious, like owning one of only 32 limited edition sports cars in the entire world. What makes the Su-57 special isn't just its scarcity. The aircraft combines stealth technology with impressive maneuverability, thanks to its unique design features. Its body is carefully shaped to avoid radar detection, while special materials help it stay hidden from enemy sensors. Two powerful engines allow it to perform amazing aerial maneuvers that would leave most pilots breathless, while its advanced computers help the pilot track multiple targets at once. But even the most advanced technology isn't immune to warfare's harsh realities. In June 2024, Ukrainian forces achieved something unprecedented, successfully striking a Su-57 at Akbank Air Base, roughly 366 miles from the front lines. This marked the first time in history that a fifth-generation stealth fighter was destroyed by enemy action, sending shockwaves through military circles worldwide. The loss highlighted both the Su-57's sophisticated capabilities and its vulnerabilities. Despite its advanced stealth features and defensive systems, the aircraft proved susceptible to well-planned attacks when caught on the ground. This single strike dealt a significant blow to Russia's Air Force, as losing one Su-57 meant losing about 3% of the entire fleet. The incident also revealed interesting details about how Russia uses these precious aircraft. Rather than risking them in direct combat over Ukraine, most Su-57s operate from deep within Russian territory, launching long-range missiles from relative safety. This cautious approach suggests that while Russia proudly showcases the Su-50's capabilities, they're well aware of each aircraft's irreplaceable value. Adding to the complexity, Russia faces significant challenges in producing more Su-57s. While designed to compete with America's best fighters, manufacturing difficulties and economic constraints have severely limited production. Each aircraft requires sophisticated components and careful assembly, making rapid replacement of lost units nearly impossible. Compare this to the F-35's steady production line, which can replace losses much more quickly. As the Su-57's vulnerability becomes increasingly apparent, a bigger question emerges. What makes these mysterious, fifth-generation fighters so special that losing just one can shake the confidence of an entire nation's military? The world of fighter jets has evolved dramatically since the first planes took to the skies. Today, only 4 countries have managed to create these advanced aircraft, known as fifth-generation fighters: the United States with its F-22 and F-35, Russia with the Su-57, and China with the J-20. What sets these planes apart from older fighters is their combination of special features. Fifth-generation fighters have stealth technology that helps them hide from radar, advanced computers that give pilots a complete picture of everything happening around them, and powerful engines that let them perform incredible maneuvers in the air. The F-22 Raptor, America's first fifth-generation fighter, was designed specifically for air combat. It's like a boxing champion of the skies, extremely agile and powerful. The F-35 Lightning II came next, built to be more versatile. It can fight other planes, attack ground targets, and even take off and land vertically in some versions, like a high-tech helicopter. Russia's Su-57 took a different approach. Its designers wanted to create a fighter that could do everything well, rather than specializing in just one area. They gave it powerful engines for speed and maneuverability, advanced sensors to detect enemies from far away, and special materials to help it stay hidden from radar. However, building these planes proved much harder than expected, which is why Russia has so few of them. China's J-20 is the newest member of this elite club. Like the Su-57, it was designed to match American fighters, but with China's twist. It's bigger than the others and focuses on long-range missions, carrying extra fuel and weapons inside its body to maintain its stealth capabilities. What makes these planes truly special is their ability to work together with other military equipment. They can share information instantly with other aircraft, ground forces, and command centers. It is like playing a video game where you can see everything happening on the battlefield at once. But having advanced technology isn't enough. Pilots need extensive training to use all these capabilities effectively. They spend hundreds of hours in sophisticated simulators before ever stepping into a real aircraft. The maintenance crews also need special training, as keeping these planes in top condition is like taking care of a Formula One race car where every detail matters. The most fascinating aspect of fifth-generation fighters is how they've changed modern warfare. In the past, pilots had to get close to see their targets. Now these planes can detect threats from far away and share that information with their entire team. They can sneak past enemy defenses that would stop older aircraft, strike their targets, and disappear before anyone knows they are there. However, owning these advanced fighters comes with challenges. They're extremely expensive to build and maintain. The special coatings that help them avoid radar detection need constant care. Their complex computer systems require regular updates, like your smartphone. And finding replacement parts can be difficult, especially for countries like Russia that face international sanctions. Looking to the future, these aircraft continue to evolve. Engineers are working on ways to make them even more capable, adding artificial intelligence to help pilots make decisions faster, developing new weapons that can fit inside their stealth bodies, and improving their ability to work together with unmanned aircraft. As these advanced fighters reshape modern warfare, a fascinating question emerges. How do these metal giants manage to become practically invisible to radar? And which fighter does it better, the F-35 or the Su-57? The F-35 Lightning II takes stealth very seriously. From the very beginning, its designers at Lockheed Martin approached the project like architects building a house that needs to be invisible from every angle. They carefully aligned its edges, created special skin panels with sawtooth patterns, and covered the entire aircraft with materials that absorb radar waves instead of bouncing them back. Even the engine, which generates a lot of heat and could be easily spotted, is hidden behind special covers made of radar-absorbing fiber material that's easy to maintain. The result is remarkable on radar screens. The F-35 appears no bigger than a metal golf ball, making it extremely difficult to detect. The plane's stealth capabilities don't stop at radar. Its designers also worked hard to reduce its heat signature and visual signature. They even developed special controls to manage radio signals the plane might emit, ensuring it stays as hidden as possible. And the Su-57 takes a different approach to stealth. While it's Russia's first aircraft to focus on being stealthy, its designers at Sukhoi chose to prioritize frontal stealth, making the plane harder to detect from the front. They achieved this by carefully angling the wing's leading and trailing edges and using special panels that help control how radar waves bounce off the aircraft. The Su-57's cockpit canopy is particularly clever, featuring special metal oxide coatings 70 to 90 nanometers thick, which is thinner than human hair, that reduce radar reflection by 30% and protect the pilot from harmful radiation. However, the Su-57's stealthy design has some limitations. The back half of the aircraft isn't as optimized for stealth as the F-35's, possibly because of cost constraints or because Russian military planners expect the aircraft to operate under the protection of their ground-based air defense systems. This design choice reflects a different military strategy from the American approach. Interestingly, both aircraft share a common vulnerability. They can be spotted by older, low-frequency radars due to Rayleigh scattering. Think of this like trying to hide behind a chain-link fence. From certain angles and distances, you're still visible. However, this is where the similarity ends for these two fighters' stealth capabilities. The F-35's comprehensive approach to stealth has proven highly effective in real-world operations. Since entering service, it has successfully conducted missions in complex threat environments where older aircraft would struggle to survive. The Israeli Air Force, which first used the F-35 in combat in 2018, has particularly praised its ability to operate undetected in heavily defended airspace. The Su-57's stealth capabilities, while impressive for Russia's first attempt at a stealth fighter, represent a different design philosophy. Rather than trying to be invisible from all angles like the F-35, it focuses on being highly effective in specific combat scenarios, particularly when approaching targets head-on. This approach aligns with Russian military doctrine, which emphasizes integrated air defense systems working together with aircraft to control airspace. Modern air combat continues to evolve, with stealth technology playing an increasingly crucial role. The different approaches taken by the F-35 and Su-57 demonstrate that there's more than one way to achieve stealth capabilities, with each design reflecting its nation's military needs, technological capabilities, and combat doctrine. After exploring the stealth capabilities of these advanced fighters, one crucial question remains. How do these aircraft achieve the incredible power needed to outmaneuver enemies while maintaining their stealth characteristics? The F-35 and Su-57 take very different approaches to power and performance. The F-35 relies on a single, highly advanced Pratt & Whitney F135 engine that produces 43,000 pounds of thrust with an afterburner, enough power to launch a small rocket. What makes this engine special isn't just its power, but how it maintains stealth. Special curved vanes and radar-absorbing materials hide the hot engine parts from enemy radar, while a unique sawtooth pattern at the back helps reduce both radar and heat signatures. The Su-57 takes a different path, using two NPO Saturn engines that together create over 63 pounds of thrust. This twin-engine design gives the Russian fighter more raw power, allowing it to reach speeds of Mach 2, twice the speed of sound. The F-35, by comparison, tops out at Mach 1.6. However, having two engines also means more complexity and maintenance challenges. One of the most impressive features of these engines is how they help the aircraft move in ways that seem to defy physics. The Su-57's engines can tilt in different directions, allowing the plane to perform incredible maneuvers. Like a gymnast who can twist and turn in any direction, that's what these thrust vectoring engines let the Su-57 do in the air. The F-35B version goes even further, with a lift fan system that lets it take off and land vertically like a helicopter. Both aircraft showcase remarkable engineering in managing engine heat and noise. The F-35's engine includes an integrated power package that handles everything from starting the engine to controlling the aircraft's temperature. This system helps keep the plane's heat signature low, making it harder for enemies to detect. The Su-57's new engines, currently being developed, promise even better performance with reduced radar and heat signatures. Looking to the future, both fighters are set to receive engine upgrades. The F-35 is getting an enhanced engine core that will provide 5% more thrust and better fuel efficiency. The SU-57 is planned to receive new AL-51F1 engines that will increase its power even further while improving its stealth capabilities. These improvements show how fighter jet technology continues to evolve, pushing the boundaries of what's possible in military aviation. The stark difference in approach will be the F-35's focus on efficiency and stealth versus the Su-57's emphasis on raw power and maneuverability, which reflects each country's military philosophy and technological capabilities. The F-35's more integrated design has proven more successful in terms of production numbers and reliability, while the Su-57's powerful but complex system faces ongoing development challenges. This battle between power and stealth continues to drive innovation in fighter jet design. As engines become more advanced, engineers face the constant challenge of balancing performance with stealth, reliability with complexity, and cost with capability. The winner of this technological race might well determine the future of air combat. As the F-35's twin engines roar with impressive power and maneuverability, one might wonder, what advanced systems lie beneath the stealthy exterior that makes it one of the world's most sophisticated fighting machines? Modern fighter jets are like flying computers, packed with advanced technology that helps pilots understand their surroundings and make quick decisions. Let's look at how America's F-35 and Russia's Su-57 compare in their combat systems. Think of the F-35 as having a super smart brain that connects all its sensors. This brain uses 8.6 million lines of computer code, which is like having the instructions for 430 video games running at once. The plane combines a powerful radar that can spot targets from very far away with special cameras that can see in all directions, even at night. It also includes systems that can detect when other aircraft are trying to track the F-35, along with advanced communication equipment that lets the pilot share information with friendly forces. All these systems work together to give the pilot a complete picture of what's happening around them, just like having a 360-degree view in a video game. The pilot sees this information on a special helmet display, making it easier to spot and track targets. Russia's Su-57 also has impressive technology, though it works a bit differently. It uses a system called Information Management System that connects a main radar in the nose, two smaller radars in the sides of the plane, special sensors that can detect missiles, and cameras that help the pilot see at night and in bad weather. The Su-57 has about half the amount of computer code as the F-35, but it's still very capable. One unique feature is its ability to detect threats coming from any direction using special sensors built into the wings. Both planes can carry weapons inside their bodies to stay stealthy. The F-35 can carry up to 18,000 pounds of weapons, including air-to-air missiles for fighting other aircraft, bombs for ground targets, and a rapid-fire cannon that shoots 3,300 rounds per minute. The Su-50 even can carry slightly less weight in weapons, that is 16,500 pounds, but has similar types of missiles and bombs. Its cannon fires 1,500 rounds per minute but uses larger bullets. These planes have some impressive capabilities that seem like science fiction. They can share target information with friendly aircraft without giving away their position, while their computers can suggest the best weapons to use. They can detect threats from many miles away and have systems to protect themselves from enemy missiles. The F-55 has an edge in its ability to connect with other aircraft and ground forces, making it excellent for coordinating attacks. It can even control unmanned aircraft, like having robot wingmen. The Su-57 has unique features too, including a special system that can tell when parts of the plane need maintenance, similar to how your phone tells you when it needs charging. While both aircraft are impressive on paper, real-world experience is showing their true capabilities. The F-35 has proven itself in various missions around the world, with over 1,000 aircraft built and serving in multiple countries. The Su-57, with only 32 built, has had limited combat experience, though it continues to evolve and improve. Both planes are designed to accept upgrades to their systems over time, like getting a new system with better features. The F-35 is scheduled to receive new radar and processing systems, while the Su-57 is testing advanced artificial intelligence systems. These fighters represent the current peak of aircraft technology, combining stealth, advanced sensors, and powerful computers to give their pilots an edge in combat. Their capabilities continue to grow as new technologies are developed, pushing the boundaries of what's possible in aerial warfare. Thanks for watching. While you are still here, click on the link on your screen to check out another of our videos. See you there.